Hi, this is Stan. Welcome back. Well, this is my little emergency coffee station right outside of our bedroom on the second floor. You know, you can't be too careful about these things. Anytime, day or night, you want to stumble out of bed and make a cup of coffee. That's what this is for. But I've got a problem with this, and I think the solution would not be a cowbell, but it would be my 3D printer. So here's the problem I'm having. There's quite a distance between the top of the mug and where the coffee comes out on this machine. And so it ends up spattering little coffee drops all over the counter here. This bottom is not movable. So this is set up so you can make a large cup of coffee, but I just use these mugs. So I think I need something to get this coffee cup up a little higher so it's not messing things up and I have to wipe down the counter after every cup of coffee. So let's head down to the computer. As I mentioned in a previous video, I am brand new to 3D printing, so please don't take this to be an expert presentation about 3D skills, because I'm just a beginner, just learning. Anyway, I have an Ender 3 V3 SE printer, and I have a little website up here called Tinkercad, and this is where you can create some three-dimensional images that then you can slice up and use on your printer. And this is a very visually oriented software. It doesn't cost anything. It's free to log on and to do your work on here. And here you can see a simulation of the bed of the printer, and it's got a grid and things snap to the grid and all the typical CAD type functions, but it's student level stuff. But what they do have is over here they have a number of built-in basic shapes and images that you can use. You drag them in and you can start manipulating these images. So like here's a cube. You can drag that cube over and place it on the workstation there. So you need some sort of a little plastic gizmo to raise up that mug higher on the coffee maker, but it needs to be hollow on the inside so that when you pull the cup out and still drips a little bit, it doesn't get all over the plastic, but it goes down into the base as it's designed to do. So what I thought we would do is we would grab one of these shapes, and this is what they call a tube over here, so we'll put that in there. And then you can see how it's basically like a small piece of PVC pipe. I measured, and I think that about 64 millimeters in diameter and 64 millimeters high would be just the right size that I need for this coffee maker. So you can see, you can take the corner. Right now this is 20 millimeters by 20 millimeters, and you can drag it out and change the size of what you need, see, just like that. And if you really want it super round, then you can come over here and increase the number of sides. That speeds, it slows the print down actually, the more perfectly round it is. I don't need to go to that degree. I just need something for function. I don't really care what it looks like at this point. But this would be perfect for setting the coffee mug on. So here's the shape that I just quickly took from the palette over here, and I sized it up 64 millimeters high by 64 millimeters in diameter. So what we want to do is export that. So we will create a file and we will send that file to our desktop. It'll be a .stl file, basically a 3D image of this little piece of pipe. So this is another piece of software that you're going to need. It's called Creality Print. Basically, this is a slicer. In other words, this is going to take a three-dimensional image and it's going to prepare it to be used with the specific printer that you have, which in my case is the Ender 3 V3SE. So we downloaded that .stl file to the desktop, and now I want to pull it in to the slicing program. And so there it is. It looks blue here because that's the color of plastic that I have, the PETG blue, 1.75 diameter, and the print quality is 0.20 millimeters. That's my 0.4 nozzle. And now I started with PLA plastic, and that's where everybody starts. And that requires less heat to mold it, but it makes it more vulnerable to temperature later and distortions due to sunlight and heat and things like that. So you can go through and manipulate this some more if you want. I don't need to do that, but we do need to set some parameters. So we would go under Edit, and we would go in, for example, under Material, and I've set a higher, made sure the temperature is higher here, 235, and then the plate that it sits on has to be hot as well, so I have that set at 65. So 235 and 65, and those are parameters that, according to the spool of plastic I got, will make this PETG print very happily. So I'm happy with the image. I'm not going to do anything else with that other than change those temperatures and make sure that this software package knows that it's PETG and not PLA, and it knows exactly which printer I have, the V3SE. So we can go ahead and click the button and slice, and now we will end up with a file that is a G-code file, not the STL file, and that G-code can be understood by the printer. So now I'll go back to the desktop and I'll just copy that G-code file onto the little SD card that came with the Ender 3. And by the way, fingers are crossed because this will only be the second print job I've tried with this PETG plastic. First project was just this little money clip, and so fingers crossed, here we go. Okay, next let's get the machine started because it's cold. Everything is cold. This plate's going to have to come up to temperature, and the nozzle's going to have to come up to temperature. And here's our spool of PETG. And I'm going to go prepare. Preheat. And we'll pop in the memory card. And then we're going to go, I'm going to hit extrude because we have to thread the PLA down into the head. Okay, it wants to trim the filament at a 45-degree bevel. So we'll clip it at a 45-degree angle. And now there's a release lever. I'm going to push that over, feed the PETG down in there, all the way to the bottom. Let it go, and confirm. And you can see it's cleaning out the nozzle. It's just oozing some of that plastic out. And there's a little blob of melted PEG. So now I'm going to go back, print, cup stands. I want to put the calibration on. And now it's got to raise the temperatures and also set the height of the print head. Okay, looks like our temperature parameters are met. Now it's going to do a sample print along the side, and then it should jump to the center and start printing. And there it's going to work. I'm going to sit here for a minute to make sure everything is sticking. And that it's working. Well, there's going to be a fair amount of plastic needed, so we're underway. Everything seems to be stuck to the plate, and the PETG is sticking to itself. I don't see any problems, so let's let this thing work. And we're just checking in on the print. We're about halfway through. Everything's looking great. You can see the cylinder is really two separate walls with a little bit of lattice work in between. So you can see we're getting close to the end here. The total print time looks to be about 100 minutes, give or take. So that means that for this particular object we're printing, it's about 1% print per minute. There you can see the temperatures are still holding at their original settings. The fan now is up. It started out at 0, fan speed 127, and my Z offset is pretty stable for everything I've printed, about minus 2.03. Okay, we're at 98%, and you can see now it's starting to fill in that flat area at the end of the cylinder. And she's done. Not a lot of strings. I'm going to go ahead and pull the filament out now while everything's hot. Well, it's still a little warm. So let's give it a whirl and see if it's the right size. I think what I'll do is I'll measure it against what I thought the instructions that I gave it were and see if the dimensions came out anywhere near close. 64.02 tall and 63.9 in diameter. So I wanted 64 by 64 millimeters. That is wonderfully close. Well, there we are. Looks like no spills and spatters, and I've got myself a cup of coffee to enjoy. Thanks so much for watching. Hope that was fun. See you right here next time.